Hi friends, okay, we are about to begin chapter 2, multiplying whole numbers. If you have not done your Am I Ready yet, then please do that before you watch this video. And I'm going to remind you all that before you start watching any of these videos that we are going to start doing, that if at any point you need to stop and pause it, whether it's you need to catch up on writing notes or you are confused about something and need to go back and rewatch, please do that. That's going to help you so much. Okay, so we are going to start with our vocab. So our vocab is on page 74, so you should be there. While I set this up, I want you to be thinking about what are prime numbers. You may have, I hope you've heard of them before, but if you haven't, that's okay. We're about to go over it. But I want you to be thinking about what are prime numbers. All right, so my friends, if you notice here, we are going to be dividing up these two vocab words, composite numbers and prime numbers, into these two spots. Now, if you notice, we have to look at the examples down here in order to be able to figure out which goes where, okay? So if you didn't know, or you did think about this, prime numbers are any whole numbers that do not have more than two factors of itself and 1. What does that mean? That means that the whole number cannot be divided by anything other than 1 in itself. So for example, right here, see the 11? Can 11 be divided by anything else but 1 in itself? So can 2 go into 11 evenly? Nope. 3? Nope. 4 can't go into 11 evenly, 5 can't go into 11 evenly, and so on, okay? The only things that can be divided by 11 are 11 and 1, okay? And that equals 1, and that equals 11. That means that these are prime numbers, okay? So some examples, let's see here. Another example, can 7 be divided by anything else? Does it have any other factors other than, oops, sorry, that looks kind of funny. I'm gonna take that back. Not a very good 7. Can 7 be divided by anything other than 1 itself? 2 does not go into 7, 3 doesn't go into 7, 4 doesn't, 5 doesn't, 6 doesn't, but only 7 does, okay? So I want you to think of a few more examples. Another example that I have, you can't do the examples they gave you. So what about 13? Can 13 be divided by anything other than 1 in itself, number 13? Nope. Let's see here. What about 17? Does 17 have any other factors other than 1 and 17? Nope. Okay. That means that these are composite numbers on this side. What on earth does it mean for it to be a composite number? Well, my friends, if it's not prime, then it's definitely a composite number. And a composite number specifically means that it can be divided by more than 1 in itself. It does have more than 2 factors, okay? So let's go forth here. Let's see. They gave us the example of 10. 6 can be divided by 2, 3, and 1 and 6. Let's see. 15 can be divided by 3 and 5, and 1 and 15. That's more than 2 factors. What else? Let's do 100. 100 can be divided by a lot of things. 10, 5, 1 and 100, 25, 4, okay? So those are composite numbers. So explain how you decided to categorize each set of numbers. So my friends, prime numbers, I'm going to do the hashtag symbol. Prime numbers can only be divided by 1. Sorry, that's a bad one. I'm going to do that and I'll give you time to write. By 1 in itself. And I'm going to box that in because that is so important for us to remember. That means composite numbers have more than 2 factors. Okay, if you need to pause this to write it all down, please do so. I'm going to keep going. Okay, click done. All right, so we are going to go on to our next page. I'm going to set this up where it says Lesson 1, Prime Factorization. Okay, you can go ahead and start reading. I'm going to read it here in a second once I'm all set up. All right, so my friends, it says you can write every composite number as a product of prime factors. Remember, product means the answer to a multiplication problem. So you can write every composite number as an answer of prime factors. This is called prime factorization of a number. A factor tree is a diagram. So look below, see those things that look like diagrams? Those are called factor trees. That shows the prime factorization of a composite number. So my friends, you cannot do this with prime numbers because you would literally only have its number and then 2 below it, right? So this is only if it's a composite number. And basically, in order to do prime factorization, we are finding what numbers can be multiplied at its lowest number, at its prime numbers, to get us to the big number. So let's look here. It says example 1. Mr. Dempsey surveyed his class and found that his students have a total of 36 pets. Find the prime factorization of 36. So my friends, it says write the number to be factored at the top. So see here where they did 36 and 36. I want you guys to know that they are just showing you 2 different ways to do this. So if you only knew that 2 went into 36, then you can do that one. If you knew that 3 also goes in 36, they can do that. The idea is that no matter what numbers you decide to break up, eventually you will get to prime factorization, okay? As long as it can evenly go into 36. So let's do the 2 and the 36. So you choose any pair of whole number factors of 36. So what times 2 gives us 36? 18, right? Okay, and then we're just going to keep bringing the 2 down because guess what? 2 is already a prime number, so it cannot be broken down anymore. What about 18 though? 18 can be broken down. It can be broken down into 2 and 9, right? 2 times 9 equals 18, okay? Then, oh, I see another 2. 2 cannot be broken down anymore, so I'm going to bring it straight down. 9, what can 9 be broken up into? That is right, 3 and 3. Is 3 a prime number? It sure is, because guess what? Nothing can go into it other than 1 and 3. 1 in itself. All right, so my friends, let's go into this example. If we only knew that 3 went into 36, which I know you all know that more numbers go into that, let's try it. What 3 times what gives us 36? What are we thinking? It should be 12. Now 12 can be broken up. Let's do 2 and 6. 2 times 6 gives us, oop, that's a funny 6. Oh well. Bring the 2 straight down because it cannot be divided any further. 6, what times 6, or what times what gives us 6? 2 and 3. So my friends, if you notice, this and this are the exact same, they're just in different order, and that is totally okay. So the prime factorization of 36 is 2 times 2 times 3 times 3. So if you want to break it up and work backwards, to check it, my friends, we always check our work. So 2 times 2 is 4, right? 3 times 3 is 9. 4 times 9 equals 36. So we can check that off, okay? Then, let's go here. I'm going to pause for you to catch up on that. And you will need to make sure that you go and watch the next video.